Okay, so welcome back to video 2 on area between curves. Remember from last time, if we have two curves, f of x and y equals g of x, and then we had x equals a and x equals b, and we wanted to find the area that lies between the two curves. That area is going to be the one on top minus the one on the bottom dx. Okay, so let's look at a couple examples. Our first example we're going to look at is, let's look at y equals x squared minus 4x and y equals 2x. Notice there's no x equals a or x equals b here. So similar to the last one, what we need to do is, this is going to lie in between. You're going to have some line, some parabola, and you're going to have to find where these points are. How we do that is, let's set it equal to 0 and solve. Or sorry, not set it equal to 0. Set them equal to each other and solve. Then you can find that this is x squared minus 6x equals 0 by subtracting 2x to both sides. Factor out an x. So that gives that x is 0 or x is 6. Okay, that at least gives me my other information I wanted to do this integral. But now you have to think, okay, which function's on top and which function's on the bottom? So we're going to use Desmos to visualize this. Okay, so here's my pulled up Desmos here. So let me put in what my functions are. Right, you have x squared minus 4x, and then y is equal to 2x. And let's zoom out so we can see where they intersect. Desmos is nice when you have functions that intersect. They'll give you what those points are if you want to solve it that way. But if you look at the area in between, notice that the line is lying on top and the parabola, our x squared, y equals x squared minus 4x, is lying on bottom. That translate to? Well, back here, remember our area is the one on the integral, and we have 0 to 6 of the one on the top, so that was 2x, minus the one on the bottom, x squared minus 4x. And we just have to integrate this thing. So that's 0 to 6, negative x squared plus 6x dx, or negative x cubed over 3 plus 3x squared, evaluated from 0 to 6. And you can plug these in, and what you'll get is you'll get an area of 36. And so if you're not given, if you're just given, here's our two curves, what's the area between the curves, then that's how you do it. Okay, so let's do another example. This time we're going to look at some trig. So on the domain of between negative pi and pi, let y equal cosine x, and then y equal 1 minus cosine x. Okay, so do these functions intersect at all? Well, you could solve to see where they intersect. So that means 2 cosine x equals 1, cosine x equals 1/2. So then x is what? You have pi over 3 plus 2k pi. And because it was cosine, you also get a negative pi over 3 plus 2k pi. Now, but look at our domain, negative pi to the pi. So these ones don't actually matter. We only have 2 points where this function intersects. But if we're going to find the area between the curves, we need to know which one's on the top and which one's on the bottom. So to do that, we need to graph again. Okay, so back in Desmos, we have these functions. Let me change them to the functions that we want. Our cosine x and our 1 minus cosine x. Now I'll put our bounds of negative pi and x equals pi. So that's what we want to be inside. So notice, so these points where they're crossing each other, we solved that. This is negative pi over 3, and this one is positive pi over 3 for the x coordinate. But now you have to notice, look, it's crossing over. So what we have to do is we have to be careful about how we set up our integral. If we go back, so if we're back here, then we're going to want to do, it's still from negative pi to pi, but notice that these cross at a certain point. So we have to split up our thing into negative pi to, well, where's the first point they intersect? Negative pi over 3. And then the top function, which is going to be what? 1 minus cosine x minus the bottom function, dx. Plus what? Well, you just continue. Pi over 3, negative pi over 3, the pi over 3. And now they flip. It's a cosine minus 1 minus cosine x. And then the last little bit, pi over 3 till the end, which is pi of, well, the top one, if you look back at the graph, is 1 minus cosine x minus cosine x dx. And now, so we want to look at each one of these integrals separately. Okay, so what about the first one? And I'll erase the other ones for now. The first one, you'll get the integral from negative pi over 3 of 1 minus 2 cosine x dx, or x and then minus 2 sine x evaluated from negative pi to negative pi over 3. And you could evaluate that. So this is going to be negative pi over 3 minus 2 sine of pi over 3, negative pi over 3 minus negative pi minus sine of pi is going to be what? Is 0. And that's something you could plug into your calculator and get a value for. What about the other ones? Well, the last integral was the same. The only difference was we had positive and these flip from pi over 3 to pi. Okay? So the steps would all be the same. It's all the same work. The only difference is, well, now this will be pi minus 2 sine of pi, which is 0, minus the quantity, well, this is going to be now pi over 3 minus 2 sine of pi over 3, which is again a number. And then the last integral is the only one that looks different from the two. It is cosine x minus 1 minus cosine x. Which, and it's from negative pi over 3 to pi over 3. And we can evaluate that. That's going to be negative pi over 3 to pi over 3 of 2 cosine x minus 1 dx, or 2 sine x minus x, evaluated from negative pi over 3 to pi over 3. And if you do similar things to what we just did where you're plugging in, you'll get another number. And what do we do with those three numbers? Well, to get the total area, we add them up. So those ones where they cross like that can be a little annoying, but they do exist, and you will see some of them in your homework. Okay, so we have to do something special with that one. Now for our third example, I would just like to look at a very special case that's a little different from what we usually see. Okay, find the area bounded between these two curves. So let's switch over to Desmos. Okay, so here in Desmos, let's just clear what we have so far. Now, our functions were x equals 1 minus y squared and x equals y squared minus 1. Okay, so we could solve for y and do it the way we've done it before. But that might be a little tedious. Notice these square terms that we have here. So our way of thinking about this is these are sort of parabolas on their sides. So if I could somehow integrate y instead of x, it might actually work out in my favor. What I actually want is, well, let's see if they let me do it. Not. Okay, my computer's going to be a little bit of a pain, but okay. Here's what I have. So this is the area I want. And so it's sort of, if you would flip it 90 degrees, you get something that's closer to what we're used to. But that's not what we have. So we don't have to integrate it with y, but that might make our lives easier. So back in the problem, we want to integrate it with respect to y now. So you're going to want some integral, and I'll write it down here, integral from, I'll call this c to d, of one of the functions f of y minus g of y dy. So it's up to us to decide which function is quote-unquote on top, or if you're thinking about it in terms of y, that would be to the right, which function and which functions to the left. And we also have to think about what are these limits of integration. Well, remember they intersected, so we just have to solve this equation, see what we get. Well, add 1 and add y squared to both sides, you'll get 2 equals y squared. 2y squared, so 1 equals y squared. That is y equals plus or minus 1. So that's easy enough. We're going to want some integral from negative 1 to 1 of some function minus another function. So parentheses minus parentheses dy. So we want to think which one has a higher, which one lies farther to the right. Now when thinking about this, I want to think on the interval negative 1, 1, if I flip the x and the y's, if I took y equals 1 minus x squared and y equals x squared minus 1, and I graph those on my graphing calculator, which one lies on the top and which one lies on the bottom? So what you'll get is that our downward facing parabola lies on the top and our upward facing parabola lies on the bottom. So what does that give us? Well, since this one's on the top, this one will lie to the right. So this is where we put it, 1 minus y squared, and then y squared minus 1. And you could go on to Desmos and verify, but that is how one of the ways you can think about it. So we can do this integral. This is negative 1 to 1 of distributing this negative sign. You'll get 2 minus 2y squared dy. That is 2y minus 2/3 y cubed evaluated from negative 1 to 1. Okay, so this is going to be 2 minus 2/3 minus, plugging in negative 1, you get negative 2 plus 2/3 or 4 minus 4/3 just by distributing the negative and combining the fractions and the whole numbers, or 8/3 is the area between those two curves. So even if you get something that sort of looks similar to how we had implicit functions back in chapter 3, you could still do this idea of area between the curves. So I can take any questions on down in the comment section or by Canvas questions. Feel free to ask. There is only one more section we're going to go over. It's called Volumes of Revolution, and I will see you all for that section.